Our learning target is 7.2. I know the steps needed to perform a stoichiometric calculation and can use them to solve problems. So we need to define and explain stoichiometry, determine mole ratios from balanced equations, and then know and use the steps to get your calculations. So what is stoichiometry? It's like a recipe. Okay, so for example, if I need 2 graham crackers, 1 marshmallow, and a Hershey bar to make a s'more, and then I have 22 graham crackers, plenty of marshmallows, and Hershey bars, how many s'mores can I make? Well, if I have 22 graham crackers and it takes 2 per s'more, then I can make 11 s'mores. Okay, so you already know how to do this. We just have to apply it to chemistry. So it's the quantitative analysis of a chemical reaction. It's going to give us what we call the theoretical yield, which we'll talk about in the next learning target. Now, if we have a balanced equation here, all right, the little lowercase letters are your coefficients, the uppercase letters are your compounds. If we start out with a given amount of A and a given amount of B, we're not going to have any C or D, okay, because our reactants have to react together to produce the products. Now, as the reaction proceeds, what's going to happen to A and B is they're going to decrease down to 0. And as A and B decrease, then C and D are going to increase. So we're going to react A and B, they're going to react, they're going to rearrange, they're going to form our products C and D. And they do this in a ratio that's based on their chemical equation. And we can use math to analyze this quantitatively. So here are the steps. You need to pause the video and write these down. You always have to read the problem. Then you're going to underline given information and circle what you're trying to find. You're going to write and balance the equation. Now notice this is starred. It's a very important step. You have to have the balanced equation. You're going to label the equation. So I'll show you this. List the known and the unknown on top of the equation. You're going to make a mole chart, and we'll go through that. And you're going to use your mole bridges to determine how the amount of moles change during the chemical reaction. Then we're going to convert moles to our desired unit. Oops. And we'll have our final answer at that point. So let's look at a mole chart. So again, here's our balanced equation in generic form. Your mole chart, when you label your equation, X will be what you're given in the problem, and then let's say we're trying to find D, okay, that'll be our unknown. So this will depend on your problem itself. So we're going to label that on our equation so we don't have to keep going back and reading our problem every time. And then your mole chart is going to look like this. Let me move this out of the way here. Okay, so we're going to have our conversion factors. We're going to have moles before the reaction. Our XN means reaction. We're going to notice how it changes during the reaction, and we're going to calculate our moles after the reaction. So we're going to go through several problems, and we're going to see how all of these things work together in this mole chart. So let's look at our practice problems here. How many moles of ammonia can be produced from 8 moles of hydrogen reacting with nitrogen? So as we read our problem, we're going to want to circle and underline. So they tell us that we have 8 moles of hydrogen. Now reacting with nitrogen is information that you would need to write your balanced equation if it were not given. How many moles of ammonia? So if you're trying to figure out what you're looking for, look for words like how many, calculate, how much, and look at what follows right after. So in this case, we're looking for how many moles of ammonia. Now we've got our balanced equation here. That's given to you. If not, you've got the information to write in balanced equations now. So we want to label our equation. So we have 8 moles of hydrogen. So H2 is our hydrogen. So I'm going to put my 8 moles above hydrogen. And I'm looking for moles of ammonia. So question mark, because that's what I'm looking for. Always put the unit. Now, why I do this is so that I don't have to keep going back here and reading the question each time. So now I can see, oh hey, I've got 8 moles of hydrogen. I got to figure out how many moles of ammonia. All right, so this first line here, conversion factors, these are the conversion factors that get me 2 moles. I already have moles, so I don't actually have to have any conversion factors here. Alright, so what I'm going to do is notice that I start with 8 moles of hydrogen. So I'm going to put 8 moles down here in my moles before reaction row. So this is how many moles that I start with. Now remember, in the little graphic we looked at, we start with 0 moles of product. Ammonia has not been produced yet. Okay? And because nitrogen's not involved in our problem right now, we need it for our balanced equation, but it's not going to be involved in our numbers. We're just going to leave that column blank. Alright, now the change during reaction comes from our mole ratios, okay, or the mole bridge. So the mole ratio is going to come from your coefficients in your balanced equation, okay. So 3 moles of H2 are going to produce 2 moles of ammonia. So my 3 and my 2 come from this 3 and this 2. So for my hydrogen, remember that your reactants are going to be used up. Okay, so I'm actually going to lose all 8 of my moles, and that's going to give me 0 moles of hydrogen at the end, which is what I'm aiming for. Now I got to figure out how many moles of ammonia I'm going to produce. So if 3 moles of hydrogen produce 2 moles of ammonia, then if I have 8 moles of hydrogen, that would produce X moles of ammonia. Okay, so when I do my cross multiplication, you're going to notice that I end up with 2/3 times 8. Okay, so when you look at your fraction, you don't have to do this every time. If you look at your coefficients and you put the coefficient of the column that you're in on top and the coefficient of the column that you started with, okay, on the bottom, times the number of moles, it'll give you all of this math without having to do it every time. So if we were going to do the fraction for nitrogen, it would be 1/3, and we would lose it because it is a reactant, and that would be times 8 as well. So if we're going to do the fraction for hydrogen, it would be 3/3 times 8. Okay, so notice that there's 3's on the bottom because 3 is what we're given, and then 3, 1, 2 are the coefficients from the top. So we do the math here, and we don't ever leave this as a fraction, all right, and we get 5.33 moles of ammonia, and we're going to put that in a complete sentence, are produced from 8 moles of hydrogen. Let's look at our next example. Notice we're using the same balanced equation for this one. So how many moles of nitrogen will be needed to produce 1.5 moles of ammonia? So let's label our equation 1.5 moles of ammonia. We are looking for moles of nitrogen. Now notice here they're giving us a product and asking us how much reactant will be needed. So we got to do this just a tiny bit different. So again, conversion factors we don't need because we already have moles. Okay? So the moles before the reaction, remember that ammonia is a product. So we're still not going to have any ammonia. We don't know how many moles of nitrogen we have, so we can't put anything in the moles before here. That's what we're trying to find. We do know that when we finish the reaction, we produce 1.5 moles of ammonia. So we can work our way backwards here. Okay? We also know that when we finish our reaction, there will be no more moles of nitrogen. Okay? So if we work our way backwards and we look at our fraction, we get 1 mole of nitrogen produces 2 moles of ammonia. Okay, so X moles of nitrogen are needed for 1.5 moles of ammonia. So the way we get our fractions from that, ammonia is where our given is. So that 2 is going to be on the bottom of every fraction. So remember, there's plus signs on the products, negative signs on the reactants. Okay, so the top of the fraction is the same as the column that you're in. And in this case, we're using our 1.5 that's given. So notice that if we start with 0 and we want to produce 1.5 moles, that's what we get. Okay, so here we have our 2 on the bottom. We're going to put 1 on the top for our nitrogen. And if we do this math, you get 2x equals 1.5. So to solve for x, we divide both sides by 2. So x equals 1.5 over 2 times 1, right? Okay, so 1 over 2 times 1.5 goes in the box. So again, working backwards, when we do this fraction here, we end up with 0.75 moles, okay, of nitrogen, and then this is actually our answer here. Okay, so 0.75 moles of nitrogen are needed to produce 1.5 moles of ammonia.